To make our second PV function, I'm going to start out by copying and pasting our old code. We've already got some stuff that's working, so let's just copy it, move down and paste it. Again, when I paste it though, I want to go ahead and make my adaptations. I know we can't have the same name, so let's call this second PV function, and let's also change my output to second PV function. That way those two match. Now we're going to need to add a little bit more to this function. That way we can handle a different amount of future value and also a different number of periods. To do that, what we're going to have to do is first initiate new variables for that. So to initiate a new variable, we use the command dim. This is short for declare in memory. What it's doing is it's setting up a space in memory for a variable to exist. So in this case, we're going to call the variable future value. What type of variable? We're going to make it a double. All right, let's talk about variables for a second. Now, variables within the computer can really be any number of things. We've talked about them as numbers. You could actually have a word in a variable. You can even store things like entire Excel spreadsheets as variables. The important thing about a variable is it refers to some kind of object, and that object is then stored in the computer's memory at a certain location. So when we create this variable called future value, it's essentially like a cubbyhole. In that cubbyhole, or think about a locker, it's basically taking something and storing it in there. So for example, we might store a number, the number 2, in that variable. And when the computer needs it, it can go and say, hey, what's in that cubbyhole or variable? The number 2. I can now do something with that. And more abstractly, it can really be anything that we want it to be. Most commonly, it's going to be numbers. It can be multiple numbers, and we'll see the flexibility that comes with variable types as we do a number of different examples along the way. For now, let's just leave it as dim future value is double, and we'll do our second argument we also need, and we'll do dim number periods as double. All right, so now we have the number of periods and the future value in there. This allows us to then update our function. Let's take the future value, right? That's what we're trying to discount, so we can substitute that in. And instead of raising to the 1, we can raise to the number num periods. All right. So one thing I want to show you is sometimes you'll get a little sloppy and say you'll hit enter like this. All right. If you hit enter, you see this error pop up that says compile error expected expression. Now, whenever this happens and you see this red text with a warning box, you have to hit OK to dismiss that warning box. But the red text doesn't go away. It's warned you that you didn't finish your expression. And in this case, the expression I didn't finish was raising this denominator of 1 plus r to some period, to the number of periods, because I hit enter at the wrong place. So because that line's not finished, I have to finish it before it'll turn on red. I can just backspace, properly go to the end, then hit enter, and now my line works again. So whenever you see that pop up, it's kind of telling you there's something wrong in that line. You got to troubleshoot and figure out what that is exactly. So now we've updated our calculations. Let's go back and see what happens in the Excel file. So we have to type our new function, second PV function. Again, our interest rate goes in. We haven't put any more arguments within the parentheses yet. We just declared the variables inside our code. So we're getting a value of 0. So let's try to figure out what's going on. Well, now we can go back to our code, and we notice that we've initiated future value and number of periods, num periods. We did dim as double for both variables. However, we haven't given an initial value to those variables yet. When we initiate the variables with this dim statement, they're automatically set to basically empty or assumed to be a 0, right? They're either a 0 or an empty string, depending on if it's a double or a string variable. So in this case, what we need to do is assign a value to those variables. So we could say future value equals 1. Num periods equals 1. This is our way of telling to the computer, hey, where you have that variable stored, that locker or cubby, put the number 1 in there. And we're going to do that for both future value and number periods. Now that we've done that, if we flip back, now we can rerun our function. And now we're getting the right answer again. However, it's not really adaptable yet, right? If we change the future value to $2, it's not changing because it's not an input to the function yet. Instead, we've effectively hard-coded it in by setting those values equal to 1. However, we are a step closer in that we have incorporated those variable values into our calculation. Before we move on here, this is an important place where we can add some commenting. Here I'm going to say initiate variables. And right after, we can say set variables to initial values. Just describing again what we're doing along the way. Sometimes I like to space things out so I can kind of block it in chunks, and it's just a little bit easier to read. So now we have the second function done. Again, it's not as dynamic as we'd like, but that's where we're going to build for the third function.